So I think for the sake of the video, I'll do it in English. And today I want to talk about chaos engineering, and especially in the cloud native and cloud era, and why it's relevant to us today. So I come from an operations background, and I've been for over 10 years at Tikal. All these icons are the things that I like to make my LinkedIn profile, call recruitments, and I'm available as Hagzag and all these different social networks. It's a very interesting topic, especially for me, as someone that came from operations and IT, and slowly climbed into software development, and eventually DevOps, SRE, and as you will see today, a little bit of chaos engineering. And chaos engineering means so many things to so many different people, and in the background there's this mind map on Kaggle, which talks about different companies which are actually dealing with chaos engineering on a daily basis. And what all of these people are saying in one word is we're trying to build trust into our systems. And things are failing, and we're trying to be agile, and we're trying to do things very fast without breaking things. And it doesn't matter really who you're asking. So I'm one of the tech leads of, and group leads of the DevOps team at Tikal. We're spread a mixture of DevOps engineers, SREs, and I think that in the coming future, we'll probably be doing a lot of chaos. When I go around to my colleagues, my peers at Tikal, and my customers, and I'm asking questions like in the front end, all the challenges that they have there. I mean, we meet frameworks, design patterns, all kinds of code generators, all kinds of different build tools and different processes. What a CDN falls down and there's no caches. There's so many, moving parts we need to actually take care of. It's a lot of chaos to deal with. I mean, personally, I'm going to focus on DevOps and SRE, but I think the guys in the front end and the back end have their handful too. And I think that we're here in a way to help all of you together. And if you heard Greg earlier from Netflix, it's an all hands-on situation. Most of the companies that I consult with, we try to be, and some of you faces are very familiar, not only because you're my teammates, but some of you are my customers. And like I said, over 10 years, there's a lot of faces here. And there's a lot of challenges and a lot of technologies coming in, and protocols and communication channels, so many things that are changing in the back end. And really the commoditization of what's happened to the cloud is also something that we're, again, accumulating. In the DevOps, there's been a very big change. Like I told you, I came as an operations guy or an IT guy. Writing code wasn't something easy for me. I never actually learned how to engineer software or how to build complex systems. And in the past 5 years, DevOps was like the elephant in the room. Everything that was not related to directly to back end or to front end was actually in our domain in a way. A lot of technologies, and all we're trying to do basically, or the third thing that we've been trying to do in the last decade or so, is basically build that trust that I was talking about. Because systems are failing, we've heard that from Netflix, a company which grew very fastly, and you'll probably hear the word Netflix quite a bit during my lecture, because I think they were the key influencers of this domain. Building trustworthiness in systems is very hard. We have best effort infrastructure. I mean, if we take a look at, I think earlier Jeff Merson mentioned the fact that we're using free cloud resources. Prototyping has become very easy to do. Anyone can just, go online and just get an instance and do something. Or someone mentioned serverless before. You can actually have an entire application running on the free tier of all these cloud providers. And I think this brings in a new notion, or it's not new when I'll do some historical background on what chaos engineering is, but we've reached this point of saying, guys, let's start experimenting in production. And this is really something that if I stood here 10 years back and told you guys, you'd probably throw tomatoes at me, like the guy from the puppets. One of the questions I've asked myself when I started researching this field is, isn't this like another type of testing? What's the difference? So I think that the traditional testing that we're doing and we're going to still continue to do, from unit testing, integration tests, regression tests, performance testing, that doesn't change. What changes is where we actually run those tests. And this is actually something which, again, I'll look at the evolution a bit later on, but what we're seeing is the hypothesis-driven experiments. So basically what we're actually doing is we want to basically look at our system, define what our steady state is. We'll talk about how to do that in a sec. The second part is we want to actually challenge that hypothesis on a daily or weekly or monthly or really on an ongoing basis. I mean, so very similar to how we started practicing CI and CD and all the different technologies we've seen on the last decade. We want to keep doing that and keep challenging those limits all the time. We want to be able to use those insights, those experiments that we ran in production should actually produce monitoring, logging, very accurate information, which should actually use that information to create action items for my different teams. We're not looking to solve problems in production, fixing them without communicating them out to our colleagues. We want to make sure that the knowledge that we accumulate during these experiments is actually something we can share among our team. This is something that, by the way, we try and do as DevOps as much as possible. We try using communication channels to communicate changes. I mean, if I told you that a build, again, 10 years ago, a build triggers a Slack channel telling everybody what's going on, or sending an email, or doing, again, notifying different systems, probably wouldn't be feasible or possible. But we've been doing that for the last decade, more or less. And if you do this process over and over and over again, it's eventually like taking a vaccine. Becoming immune to those kind of problems that you ongoingly test yourselves against. So chaos engineering is basically like injecting that vaccine and immuning yourself from those disasters. It's increasing the resilience in systems, because if systems are always challenged and always are pushed to their limit in the right way, so we can actually discover all these vulnerabilities on an ongoing basis and be able to, again, deal with them before they create an outage. And this is a bit, of, again, testing in production. So what it isn't something that we want to do like pulling the plug. And I recall one of my colleagues telling me the other day when they're developing this Ansible module, so the guys, the QA there at the back, and you can laugh if you like, they just pull the plug out during the module running. So we can't really prepare to every disaster which might come. When we look at a new technology or a new, what we call a trend, and when we start saying, guys, let's start doing this, or let's look at this technology and see if that fits for our work line, I'm asking myself, where does it meet me and where did it actually come from? So I think so far I was not bad. I said Netflix 3 times. But from now you're going to hear a bit more about what Netflix did, I think. In 2010, Netflix makes, I think, a very big decision of moving to the cloud. And basically, their first partner was, and I think still is, AWS. And it's not the AWS that we learned to love or hate, depends on your project. There was no autoscaling then, or autoscaling was just in its really first stages. You had to actually move things around your own. You had to be aware of that. You had to be able to monitor everything that's going on. And again, communication here is another key success factor to that. In 2011, we see a white paper from Berkeley University saying failure as a service, which basically means I need this external entity to be able to actually sit there and tell me how I'm performing. and how I'm working. And I thought it was a new idea. But building resilience into systems is something we've been dealing with for over 3 decades. One of the interesting anecdotes on one of the Velocity conferences, I think in 2012 or something, says that the surprise is not that there are so many accidents, the surprise is that there are so few. There are so many, the systems are very complex, and it's quite surprising that they don't fail and fail and fail again. And when we ask ourselves what resiliency is, so it's dealing with a lot of unknowns, dealing with a lot of events. You need to be able to say how my system should be, in what state it should be in that steady state. What defines that steady state? What kind of monitoring, logging, and alerting do I need to cuddle my application with? And when we're looking about distributed infrastructure, that makes it even much, much harder. What happened between 2011 to 2014 at Netflix is that Netflix themselves, from what I understand, have built trust into chaos engineering. So they said, guys, if we challenge our product all the time, and if we own it all the way, like we heard Greg in the keynote earlier, we'll get there much faster. So it took them even almost half a decade to say, we're buying into chaos. In the same year, we find Gremlin.com, a company which actually takes these principles of chaos engineering and gives them as a service. And one of the things that I asked myself is, what are those tests? What are they're doing? And looking at the Shamian Army and Netflix tools like all the Chaos Monkey suite, which is quite a bunch of tools if you ask me, what are they doing? They're doing very low-level, small tests to actually challenge different aspects of the application. So resiliency is something that's here to stay. We want to keep that. We want to be able to build systems that we can trust and rely on. And the way to do that is to continually experiment in those environments. The only thing we need to remember is we're running in production. So we need to be very cautious of how we do these things, how we monitor those experiments, how we make sure we don't do outages, like I mentioned before. When I look at customers today, I'm asking myself if I come to a customer and say I'm going to do some chaos engineering on you, that doesn't sound very good, doesn't it? Does it? But we all have chaos. The majority of the customers that I've been dealing with over the last decade are moving from the monolith model to a microservices model. All these communication channels that are now being built around those microservices, regardless to if you're running in Kubernetes or Amazon or Google, these channels need to be monitored. They need to be stabilized. They need to be able to adhere these turbulent conditions. A turbulent condition, for who's not familiar with the term, is when you're in the air and the aircraft start to turbulate, start to move and to shake. That doesn't mean that we're crashing, but it means that the aircraft is now challenged with actually what's going on. This is very similar to what's happening to our applications. As a hypothesis, I have a Kubernetes cluster. And one of the nodes just felt like failing. And as we all know, shit happens in production all the time. We need to be able to stop at this point and say, is this okay? Maybe that's fine. Maybe I don't need all those servers. I need the elasticity. That's part of the era we're in. We want to be able to grow maybe to the volume of Netflix. We want to grow to the, potentially at least, grow to the volume of Google and Amazon and so forth. If we don't practice these different technologies and tools, which we'll talk about in a minute, we'll never get there. We'll never be able to challenge or reach or plan to that scale because the planning will take us years and years and years. And maybe this is back to normal. I don't know. So how do we practice chaos? And I mean, a lot of faces in the crowd here. Feel free to ping me at the end of this, and let's talk about doing some of these things. Let's start doing chaos days and game days. Let's start planning disasters. Let's start planning challenges to our infrastructure. So there's a lot of companies worldwide doing these things. PagerDuty is also a good example of the, what is it called? Failure days or failure Mondays. So everybody comes to the office and start breaking things and start monitoring stuff and start showing different teams. And just by talking to each other, and I think Greg mentioned that before, it's very frustrating for a DevOps engineer or a backend engineer or a front-end engineer or anyone to want to be able to make a change and he can't do it because there's so many hurdles in the way. There's so many biased people or ideas. So let's try to collaborate. And collaboration, I think, is key here. So how do I experiment? There's a lot of tools. And if in the past, like the first slide would be Wikipedia, so today it's GitHub, and there's so much information here. I've used this for the last 6 months, more or less, to actually learn how to do this, how to actually be able to challenge production without breaking things. Don't get me wrong, I do break things. One of my customers here is laughing, of course. So I think the first thing you need to be able to control in order to start practicing chaos is automation. So if you don't have automation for every single thing, and I mean every single thing, it just won't work. You can't scale an application and shrink it back without automation. Well, you can. You can sit down and start pushing knobs in consoles, but that's not something that we really want to do. And I don't think I need to expand more on this. If using Terraform or Ansible or any other tool as a service or open source, of course open source, if you ask me, it doesn't matter. You need automation, nekuda, as we say in Hebrew. Monitoring. Monitoring is really, if you're already done automation and you know how to monitor your KPIs, so this part is really your ROI, the way that I see it, your return on investment. This is where I can actually come to my management and say, guys, the automation I've been doing for the last, I don't know how many years, is paying off. See how quick we can fast, yes, quick we can scale. This is a good entry point to say, we can start experimenting because we have the know-how. We have the ability of how to do that. We know how to measure that. Sorry about the slides. If you don't know how to take or reach your root cause of an error, you can't experiment on that. I mean, you don't know what the root cause was. So if not all the teams dealing with that problem are on the table discussing it, it won't work. And I think that in the past, SREs and IT has been looking at this the wrong way around. They've been looking at something called SLA, Service Level Agreement. And that's those three-letter abbreviation forced us to actually be less innovative because we were always keeping our cards close. We want to keep stability. We don't want the business to shout at us saying you're breaking things. This has also changed a bit in the past 10 years or so. We're now measuring how quick the change failure rate is. We're not looking at how many failures. We know we're going to fail. The question is how quick are we going to recover from that failure, and can I keep making that rate lower and lower or higher and higher, depends how you look at it. And really all the metrics we're looking at are looking at how quick can I recover from issues. How quick can I push a change? How quick can I learn of what I actually did? And game days or experiments, and it don't have to be like a whole day, it could be a few hours. It could be 2 hours that you're running a scheduled experiment to the relevant teams that they're working with. And when they get back the feedback, it's awesome. They know what to do with it. Facebook, LinkedIn, Google, they're all doing it in a way. Mark Zuckerberg saying if you're not breaking things, you're not moving fast enough. I'm not sure I'm ready to break a production system, but I'm willing to break a service, which is not one of my key success indicators, right? So if I have an e-commerce site, and let's say my payment system is down for 20 seconds, nothing happened, or 20 minutes maybe. If I'm using Amazon Prime and I'm shipping the next day, that system can't be down, right? So it really means that the rate and the high availability of each component really depends on your business model. It's not only a DevOps practice, if I haven't stressed that out yet. There are many layers that build our applications. If you look at a very small fraction of one of our microservices, and the good example that keeps coming up in all these talks about chaos, what happens if my cache just isn't there anymore? What do? What chain reaction that might cause? When we heard about this word chaos in chaos engineering, so you read about this thing called the butterfly effect. So this butterfly flings their wings somewhere across the ocean, and somewhere on the other side, there's a tornado. The relation between the butterfly and the tornado is very, I don't know, there's no sense in that, really. But if a cache falls and one of my services fail, so that's a very similar, maybe, analogy to that problem. What I think chaos engineering does is basically gives you that dial, which you can say, I want to tweak that specific part of my application. I want to take my, again, maybe my online shop, or maybe for Netflix, their streaming service, or for Amazon, it could be their shipping service. It could be many different things for many different people. But if if I'm able to find that specific part, the specific service which makes me scale up or scale down, those are the things that I want to be able to tweak on a regular basis. So measuring, which means logging, monitoring, good RCAs, issues. Of course, you need to be able to track all these things. You need to be able to take that data and experiment with it on your infrastructure, on your systems, on your applications, different levels. And eventually, you probably immune yourself from those issues. And I think the biggest change that we're seeing, if we talked about 98, talking about resilience, 2010, the first, I think, technological company that actually takes that paradigm or practice and implements that into software systems. So we're seeing like this shift left, really. We're seeing that we're actually starting to plan these experiments as we plan our applications. We want to be able to say, what kind of conditions do my services need to adhere in order to be productive? You can't do that without tools. Sorry for a sec. I think that if I haven't said Netflix enough, so one of their biggest contributions isn't the actual tools that we're using. Although Spinnaker is, again, open source, and Chaos, different Chaos Monkey components are also open source. But what we've learned from those experiences is, for example, Gremlin, which I just mentioned earlier. So Gremlin provides, as a service, the ability to run this Chaos agent on your infrastructure. Doesn't matter if you have an EC2 instance or a Kubernetes cluster, there's a service that actually listens to issues, to problems, to get those experiments injected into him to actually run those issues in production. And the way the tools are built, and I'll show you a few examples in a minute, is how when I plan my experiment, when I say I want to be able to be uptime 100% of the time, what does that mean? What kind of measures can I take to actually challenge that hypothesis? Okay, so how do I take that steady state which says all my services are up and my APIs are available, how do I make that scale? How do I make that keep going? So monitoring is the way for me to know that it's up and running. But how do I know what the limit is on how much can I be uptime? How many connections can I adhere on my services? What's my limit? And this is what that experiment will do. But if I push it too much, I might reach that outage issue I don't want to reach. So I really need to do it, what Gremlin call it is contain the blast radius. So basically, if you do set, for example, an attack on one of your services, be gentle, be subtle, do it. I mean, if you can add 20% maybe traffic, but if you add 50 or 100, you probably fail, right? Unless you have all the infrastructure to support that auto-scaling part at the back. And this is exactly what we want to be able to test. We want to be able to say, if I can reach, let's say, 1,000 sessions per minute or whatever, and I want to reach 50 sessions per minute, let's put that into experiment. Let's measure that. Let's see how this number of sessions is actually working. Does it create some kind of butterfly effect in my infrastructure? And this is the last part is the squasher scale. So if it's too high, I squash that experiment, and I say, I either scale it up or down to fit my needs. And this is why it's not the tool that you're using, it's what you're doing and how you're doing it. You don't have to use Gremlin or Chaos Monkey. You could use shell scripts to do that. You can use Ansible playbooks. You can use Terraform files to do that. You can use any tool that you want as long as you know how to measure that and record it, dial it up, dial it down. Plan those game days. There's a lot of tools online. Gremlin, by the way, are one of the, they have a lot of information online of how to do that. They're, by the way, I think one of the biggest contributors after Netflix to that domain. And the second tool that we're seeing on the right-hand corner, I'm going to show an example of, is something called Chaos Toolkit. Chaos Toolkit is basically taking those 3 steps we talked about: experimenting, controlling the radius blast, and then dialing it up or down. So basically, very similar to CI, we have this JSON notation of saying, this is the steady state, this is my hypothesis, this is how my system should be up and running. So all my pods in this example should be up and running, and it doesn't matter what again, the name is. It could be for every application, you could have one of these files which actually represents their steady state, that hypothesis. That basically tells the rest of the team or the rest of the teams in my company, guys, this is what you want to challenge. The same tool has that challenge within it. The method they're used by a Chaos Toolkit is basically, let's run this pod termination, and if I have like 3 replicas, what would happen is I'm using the reconciliation loop of Kubernetes to relaunch that instance, which basically means I'm dealing with that turbulence, that undefined state, which I wasn't sure how I could design my application even to work like that. I had no idea when I started off how many instances of the application would be running. What I'll find in these kind of situations is that if I don't build a resilient microservice, it won't work. If I lose a replica and I didn't scale my application correctly, I'll be losing connections. I'll be creating an outage. I can't do that in production. So I need to do that very slowly and carefully. There are other tools. Well, I'm going to give an example of 3 or 4 of them, and then I'll finish with that. These are tools which are actually, there's no experiment in them per se. You don't define it in code, but you can say something like Chaos Cube, and by the way, again, the Chaos Monkey toolset also have these Helm charts which you can use to deploy on Kubernetes. What these tools can give you, and I'll run a bit because I've been marked at the end that we're out of time, but there are tools like QBench and KubeAudit and many, many others. All these tools do is they scan your workload. And the reason I'm talking about Kubernetes especially is because Kubernetes gives you resiliency built within it. When you launch a Kubernetes cluster, if it's on EKS, Amazon, or Google, or Azure, or wherever you choose to run your cluster in, you're already running under an auto-scaling group. All you need to do is add an annotation to your services, and you're auto-scaling, which is awesome. Think what Netflix you need to do in order to be there. We can do that in I don't know if a blink of an eye, but quite quickly, actually. KubeHunter and KubeAudit and ChaosCube are examples of tools that I can use to start to understand where to start to experiment in my system. KubeBench helps you, ChaosCube can work in like a dry run mode. So basically, if I annotate my services with that ChaosCube annotation, what will happen is that I can just look in my monitoring system or my logging system and see things failing even though they didn't do it. It gives me like a dry run of what could happen. And when I move it from dry run to, I don't know what you call it, wet run or real or production, it starts breaking things. It starts taking replicas down. So if you're launching applications with one replica, you'll have downtime. You want to make sure that doesn't happen. By the way, it's not really downtime, but I don't have time to get into that right now. KubeBench and KubeHunter are doing similar stuff. For example, KubeBench checks, do you run applications under a root user? You want to make sure that security-wise you're okay. And many, many other things. So I think to summarize, we want to be So to summarize, if we go through these three different disciplines and we collaborate, eventually what we'll do is build much, much better and resilient systems. Thank you very much, and if there's questions, I'm here.